Hi everyone, this is the solution key to part 4 of the Alkene practice problem set. And this one we're focusing on the halogenation, halohydration, and haloalkoxylation reactions. And if you haven't done so already, I recommend watching part 4 of the Alkene note series, which goes through the details of this reaction prior to doing these problems. All right, so for this first one, we first identify that we have a chlorine. And so we know that this is going to be, we're going to halogenate the alkene at some point here. And then our solvent here is CCl4, which is a non-nucleophilic solvent. And so that's just acting as a solvent. It's not going to participate in the reaction at all. And so we can just draw in the final products where we do the anti-addition of the two chlorines across that double bond. And one thing to note is that we do have to draw in both products here. You cannot write plus enantiomer for this one because these two are not enantiomers because of this methyl group that you have over here. And so these are actually diastereomers. And so for if you're solving a problem set or on an exam, you want to make sure that you draw in both of these products. Paying attention to how that these two are anti to each other. All right, in this next one, we have a bromine and a alcohol as a solvent. And so here we can see that we have a nucleophilic solvent. And so when we form that halohydrin from that first step, or bridged toluenium ion, a bridged toluenium ion in that first step, we can next have that alcohol come in attack at the more substituted position here. And so we end up forming this as our product. And then we can also have the other version where that added chain here is dashed. And so in this one, the bromine and this chain are added on anti also. We just happen to have two hydrogens here next to the bromine. And so there really isn't stereochemistry that we can show to show that they're anti, but the mechanism technically is still anti. And so the only stereogenic center we have here is going to be where that oxygen is. And so we have a pair of enantiomers here. All right, for this next one, we again have a bromine here. And so our first step is to draw in that bridged toluenium ion intermediate. And so here, what you might have done next is added in a bromine, a second bromine, and attacked the more substituted position. However, here we have that this OH is pretty close in proximity to that bridged toluenium ion. And so since it's so close, the reaction that's more likely to happen is that this OH electron pair right here comes in and attacks the bromine here. And so this ends up cyclizing or doing an intramolecular reaction where we end up adding the that oxygen to the ring and forming a six-membered ring here. In here, we actually get a mixture of two stereoisomers where we have that branched or R group that comes off with that bromine can either be wedged or dashed coming off that second ring that forms. And whenever we're doing cyclization reactions, keep in mind that we're trying to form 5 or 6-membered rings. Those are the most stable rings that we could form. In general, we usually see reactions that form 5 or 6-membered rings. Reactions that form 4 or 7-membered rings are less likely. And so generally, we're looking for a 6 or a 5-membered ring. All right. For this next one, we have a bromine again, and then now we're doing this reaction in water. And so we know we're going to add on a bromine and an OH in the anti-fashion. And so here we'll end up having a bromine coming off here. And the OH goes to the more substituted position because that's where the water will attack. And so we'll get these two products here. All right. For this next one, again, we have a bromine. So our first step is to draw out that intermediate bridged tellurium ion. And so here we also have an OH within the molecule. And so in the next step of this reaction, that OH wants to come in and attack and cyclize. And so you're getting an intramolecular cyclization reaction again. And here, to determine how many total members of the ring we have, I'm going to highlight the different components. So we have the oxygen, we have this carbon, second carbon, third carbon, fourth carbon, plus that oxygen. And so we form a 5-membered ring here. So I'll redraw this as a 5-membered ring. Next, to identify where the rest of the components go, I'm going to highlight this carbon here in purple next to the bromine. And so that purple carbon is going to be on the right side over here. And I'm just kind of arbitrarily assigning which carbon ends up being in that ring. It's going to be the one next to the oxygen within the ring. And so from here, we have another piece to the molecule. We have these two highlighted atoms here, that carbon and that bromine. And so we're going to have that those carbon and the bromine come off the ring like this. And so we end up forming this as our product. And if you're struggling to identify like where the bromine ended up, a tip here is that we ended up breaking this bond right here. And so that bond breaks apart, but this one and this one stayed whole. And so that's why we end up getting that chain coming off the ring in our final product. All right, and so here we actually also form a stereogenic center. And so we also have our plus enantiomer where that group could be dashed. All right, finally, we have our chlorine here, and then we're doing this in an ethanol solvent. And so we know that ethanol is an alcohol that can act as a nucleophile. And so for this reaction, we're going to want to draw out the structure of ethanol. And so you can either do that as ETOH, or you can draw out the structure of the ethanol itself. And so for our final product, we're going to take our alkene and add the chlorine and the ethanol in the anti-addition. And then we want to add the ethanol to the more substituted carbon, which is going to be that first one coming directly off the ring highlighted in blue here. So I'll draw out the products. We'll have a wedged methyl group with that OET, or the structure of ethanol if you want to draw it out. And then here we want to have the chlorine anti to that ethanol group. And so our two products here are going to be this. And then where we have the chlorine dashed and the OET wedged. And again, the key thing that we're looking for is that these two groups are anti to each other. We're drawing both products here. All right, so that wraps up this video. I'll see you in the next one.